Okay, guys, welcome back to the lecture of biophysics. Today we are going to discuss about energy storage in capacitor. So I think you have watched my previous lecture of capacitors and the electrostatic concept of it, so that you can correlate with this lecture. So make sure you watch the video and also please make sure you subscribe to my YouTube channel, since this is my first YouTube channel. So if you subscribe and like to my video, then I can make myself motivated and keep on moving forward for providing you more affordable, valuable knowledge. So energy storage in capacitor, let's discuss. A charge capacitor stores electric energy by separating positive and negative charge. We have already know that in capacitor, plate each plate must be of different charges, like positive, negative charges. So having with certain aperture, means area, and certain separation of distance between each plate. So the energy stored in a capacitor will be equal to the work done to the charge it. Okay, so we can connect the capacitor with a battery and apply the uh, electrons or charge, so that it can charge up. All right, that's it, what it says. The net effect of the charging a capacitor is to remove charge from the one plate and add it to the other plate. So the net effect of the charging capacitor is to remove charge from one plate and add it to another. That is the way of transferring the charges in capacitor. This is what a battery does when it connect to a capacitor. So a capacitor does not become charged instantly. It takes some time. Initially, when the capacitor is uncharged, no work is required to move first bit of charge over. As more charge is transferred, work is needed to move charge against the increasing voltage. The work needed to add a small amount of dq when potential difference is across the plate is that much. So suppose this is a capacitor. So if you want to charge the capacitor, although what you can do is that for let's suppose there is a charge here which can be transferred through this electric field. So the charge can be transferred like this, from the positive to negative terminal of the battery. But one thing to be clear is that it requires a work to transfer across the capacitor. All right, it requires a work. Everything in every daily life, we all need to put some work so as to transfer our satisfaction, like that. So it's just like that. As more work charge is transferred, more work is needed to move charge against increasing voltage. The work needed to add a small amount of dq when a potential difference is across the place is v. Okay, so potential difference is simply the difference of the charges of two unlike charges. That is the main concept of potential difference. So suppose, let's say there is a charge, unknown charge here, maybe positive or negative, doesn't matter. And suppose there is a negative charge, so potential difference must be the work done required to bring this charge up to this certain distance. So it will induce attractive or it can induce repulsive according to the type of the charges here. Okay, so that is the work done required to bring it up to certain um, distance. That is the potential difference between the two charges. So the work done between the potential difference must be indicated by, for a small charge dq bringing from infinity or from some certain distance, then the work required to do is denoted by dq and is equal to potential difference between the two charges and the charge of it that locate to the infinity or to the certain distance, and which is further equate as charge, actual charge divided by capacitance. So that is the charge here, and suppose this is positive and this is let's suppose this one is negative for a while. Suppose these two charge and the charge at the infinity, let's assume sorry, so this must be capacitance having different charges of its plate. There is this plate must be negative charges and this plate must be positive charges. All right, that is the concept, and bringing that charge dq at infinity. Okay, so that is the work done required to bring to that capacitance of different charges. All right, so then the total work needed to move total charge q is equal to work done equal to integration of 0. Suppose that small charge dq is 0, point of reference is 0, let's consider. Then the charge up to there, suppose this is dq. Suppose this is positive charge q and this is negative charge q of a plate. All right, okay, of a plate. Suppose this is positive charge, that is negative charge. Guys, I'm sorry that let's see. Okay, this laser is not quite long lasting, so it's quite hard to teach with this in our iPad. But for this lecture, manage it, I will try to implement other software for teaching. So so bear with me. So the total work needed to move the charge q is equal to, so if we are going to consider the actual work done to bring that charge which is located in infinity to bring to the certain distance for consideration, we have to take the integration from the point of reference It could be origin or to the point of consideration. So suppose this plate carries a positive charge and this plate carries negative charge. Let's suppose assume like that. So to bring a charge which are located at infinity must be taken into consideration of integration so as to uh, clearly understood the work done by the charge to bring that charge. Okay, so work done is denoted by integration to the point of consideration, which is the origin. It could be to uh, cons- uh, the consideration, which is q minus q. This is positive q. So that q must be this q, and this point of origin must be the charge, smallest charge, which is going to be uh, bringing to a certain distance. Okay, so uh, work done equal to integration of integration of the uh, test charge, let's say, to the source charge q. So it is q, which is charge of that plate, divided by capacitance of the two plate, and the dq is the smallest charge at infinity. Sorry. And we all know that capacitance is will be the constant value. So with application of mathematics, we know that 1 by c, which is capacitance, can be uh, taken out, and we can integrate the charge with respect to smallest charge dq. Then we all know that by integrating, we we know that x differentiation of x with respect to x is simply 1, but integration of x with respect to x, we have to add one value and divided by same added in the powers. So this q is simply that q, and it comes power 2 divided by 2. Okay, so after that q, which is charge, is equal to capacitance into potential. So the electric potential in a z, which is electric potential in a z concept here, is now come to the conclusion that sorry, the electric potential in a z must be this pe, which is potential energy stored in the capacitor, must be work done, which is q square by 2c. So it comes out to be a further that cv square. We all know that q here is equal to cv square. So if square, then it also square, isn't it? So v square and c square, and the c in the lower part in the denominator is cancelled with the numerator, so it comes out to be potential v and charge divided by 2. So sorry. So after that, this is also possible to regard the energy as being stored in the electric field between the plate. Sorry. Uh, it is also possible to regard the energy as being stored in the electric field between the plates, since potential equal to electric field into distance of separation. So after that, capacitance equal to uh, dielectric constant K epsilon naught A divided by D. That is the value we already come across. So make sure you watch the previous video, so you can correlate with this. So we can possibly regard the energy as being stored in the electric field between the plates. We can assume that energy is being transferred and stored to the capacitor uh, in the means of electric field. All right, so potential is equal to electric field into distance of separation. Then capacitance equal to dielectric constant epsilon naught A divided by D. A is area, D is distance separation. Okay, then we can find out the value of potential energy as work done in bringing the charge towards plates as CV squared by 2 here. We know that CV is equal to charge, so this is comes out to be charge and potential divided by 2. So then that is the actual value of potential energy. So we can have the formula of potential energy as this and this, and we know that capacitance from here is K that constant epsilon naught A divided by D into what into potential. Yes, since this is a square of potential, so electric field square, distance of separation square, and then that 2 is still the same, but the capacitance is D was at the numerator, sorry in the denominator. And then we can come to conclusion that after cancelling the D also, we can get the value that K, actual value that of potential energy in terms of electric field is K times epsilon naught A D electric field square divided by 2. Area times the separation D, the volume between the plates, the energy per unit volume called energy density. A by D is area times the separation. Okay, AD is volume between the plates. All right, AD is the volume between the plate, then the energy per unit volume is called energy density. This is volume divided by 2 is the is the energy density. That is the energy density. Work done equal to potential energy divided by volume. Potential energy divided by volume. So energy density is simply energy density is simply the concept of volume of the separation between the two capacitor, and per unit of its energy is called energy density. So work done equal to potential energy divided by volume is equal to potential energy. We all need to know that this is value of it, and AD is the volume. So when we divide by volume itself, we get the energy density, and denoted by small w. Quite dissimilar with this 2w. One is the work done, and this one is energy density. But according to Indian author, energy density is somewhat denoted by something like this. Density. Yes, alright. But it depends on the author. So for me, I refer this. So make sure you also refer many author as much as you can, so that you can know the clear picture of his concept. And I must say you might encounter while preparing exam that my teaching is not up to the mark, but you must clear to your mind that every author has a different perception, so you have to go through lot of books so as to know different concepts. So for me, for this lecture, I'm willing to give only this much knowledge, and so it may not be completed the whole knowledge. So it's all up to you. Make sure you check out others. This expression is valid for electric field strength, not just that between the plates of a capacitor. Okay, this expression is only accepted to find the electric field strength, not just between the plates of a capacitor. Okay.